Hello, I'll just introduce Lukas from PixPro. I actually presented a presentation. My name's Ian from Datamine. This is just part 2 of a 3 sort of series of presentations that we're doing.
Okay, yes.
Yep, might be a little bit easier. So a little over a year ago, Datamine and PixPro sort of met for the first time and sort of built up a relationship since then. So they take care of a lot of our images that come from drones and that sort of thing, and helped us a lot with the photogrammetry side of things from the air. Lukas is a photogrammetry specialist, and he took us on a few sort of lessons in correct drone flying about a year ago now, and is a great resource for us, as the entire PixPro team is. And he's going to sort of run us through a little bit about what PixPro does before we move on to the third series into Peru, which will be more on the geotechnical mapping coming off the models that we're developing in PixPro.
Okay, so my name is Lukas again. I've been working in PixPro for 3 years, and I would like to showcase our software a little bit. Yes, I can see the video started playing, and in this video I will just familiarize yourself with our photogrammetry process. So first of all, I would like to say that in photogrammetry, input data is regular photos. Regular photos are easy to acquire with an UAV or just a simple camera, and photography is becoming a universal skill in the whole world. Photogrammetry is closely related to photography and can be learned by almost anyone. So the ease of use is inherent with this technology. So in the video, I am scrolling to just simple pictures that are made with a consumer-grade drone, Mavic 2 Pro, and just showcasing that this is the data that has been used to create a 3D scene of a certain location. So first result from the PixPro software is the initial 3D reconstruction, which is represented by a sparse point cloud and a camera positions represented in blue. The pictures were processed locally. Any computer can be used for processing, and cloud processing is on the horizon as well. Further, we can see the dense point cloud, which is a denser version of the sparse point cloud, and it represents the whole scene quite more recognizably. Third, we now see a digital elevation map, which is a surface that has been created from the dense point cloud, and it can be overlaid with a true orthophoto imagery for a more realistic representation. But finally, the most realistic representation of the scene is a 3D mesh. I am now enabling the 3D mesh in the video, and of course, any mesh can be textured for the maximal virtual reality experience, so to say. And now the texture is enabled, and you can easily recognize the scene and feel like you are in it. Finally, there's one more layer, the classic contour lines, which will be shown soon. And those contour lines are the surface represented also in 3D, but using the classic contour line map view. Each mentioned layer has a small set of parameters that can be tweaked by the user, and the whole set of layers can be generated at once for maximum efficiency. Now, for data visualization and manipulation, digital elevation map is represented in 3D and can be shaded in various options to highlight certain surface features to ensure a clear readability of the scan scene. So now we can see I just switched the wireframe view so we could see the individual cells. Also, I will switch to a different solid shading options that just represents the same surface visually differently, so certain features can be more exaggerated. Yes, for me the video is a bit frozen. Okay, let's just maybe the video will unpause again soon. I am trying to unpause the video. Ah, yes. So now different gradients will be switched. For example, green to blue. This is just for visual purposes, to have as much visual information as possible in our software. Also, we can manipulate said surface. So any unwanted features that have been obtained during the photogrammetric scanning can be deleted right on the surface. Now in the video, I will use the leveling function to delete this bush, I think. There was maybe a tree or a bush that is not wanted here. So a very simple tool based on a polygonal selection, which is drawn by the user very easily. And then just by the single click of a button, the feature is now gone from the surface. In that way, we can just get rid of the unwanted features and not have them impacting our measurements or the visual representation. And here's the second feature gone. Again, we are working in an intuitive 3D environment, and it's quite a lot smoother than the video might convey. Further, we go to the surface, to the measurements and the ease of use. Oh, yes, again, so I will now crop. I just cropped the surface. Again, it's just a tool for efficiency. I can use any part of the generated scene to have it cropped, and now it looks like that. So the main point of our software, measurements. We have made PixPro very easy to use and master for everyone. It takes on average only 2 hours to get a person started with PixPro and not much more to get it mastered. Measurements are required particularly easily and quickly. All measurements are tied to the objects that can be drawn by the user in the same layer system as our generated layers. A simple point that I just placed in the video just records its location and acts as a graphical feature. Now, a line I just placed provides you with all the linear measurements that can be done in a 3D environment. So all the lengths that are possible. A line also can be viewed as a surface profile, and the surface profile can be measured in itself. So depending on your selection, which is in real time, and again, much smoother than the video might represent, we can get specific measurements. And polygons, finally, polygons can be used for volumetric measurements. Here I am selecting a surface feature, again, just very easily and simply. I finish my selection, and there instantly on the right panel, all the measurements appear. And I can, of course, select a base surface that fits my needs the best to have the most accurate measurements possible. And even a previous scan or for example, an empty stockpile of surface can be used as a base surface for maximum accuracy and tracking in real time. Future development and ideas. So the video will now be more of a showcase of a beta features that we have in development. Here I am showing a automatic break line generation results. The feature is not yet fully developed, but we are working on it. As well as we worked on reporting stockpiles and site security using everything in the software. So for example, imagine you have this view and you need to generate a report, and you could do that inside the software without any other graphical software needed. Here I am showcasing another feature that has been developed by us. It's a blind spot detection feature. Again, good for safety, good for lookout spots, or maybe installing security cameras, and for safety and other applications. You can select various variables and just see what you would see from a certain spot on the surface. And finally, our overarching goal would be to develop a software that can do what others cannot by gathering real-life experience and practical data from industry experts. Utilizing photogrammetric algorithms, automation, machine vision means saving human work hours and making them safer by reducing the need of physical approach in various tasks. And I would just like to personally stress how easy is to do photogrammetry. And that would be it from me.
Just to emphasize on the relationship that we sort of have with PixPro, we're sort of looking, that was obviously more the surveying sort of vertical, sort of top-down sort of view of stockpiles and that sort of thing. In our next presentation, we'll be sort of showing some more geotechnical mapping features, which will be using sort of PixPro with that side on oblique sort of view of the camera. And they continue to build tools for us, and as we sort of realize that we need certain features like the line of sight and that sort of thing, that they actually came to us and said, hey, we might be able to do this, and we thought that was a really great idea. So it's continuing back and forth relationship that we have, which is working really well.
No, that really is wonderful. So what is the time taken for the entire process, right from capture to the final textured, triangulated surface?
The capture time and processing time heavily depends on the area that it's needed to be captured, the desired resolution, and on the hardware that it is being processed on. So this example that I showed is basically nothing. It's just a couple of hours of flying and processing put together. So as we scale the operation to a very large areas, we might get a process that will take 10 hours, maybe 12 hours for thousands of photos. But virtually, in my experience, up to 10,000 photos, it's just a matter of leaving your computer during the night to process the results. In practical terms, I'm just speaking from a super practical point of view.
That's really impressive. It's a wonderful to see where technology has come in this area, to be able to do that with that resolution and the capability to look at what you might see, particularly that you showed in the end of where you might set up a camera, for example, to establish what vision it would see. So optimally set up sensors around the mine. That is really fantastic.
Yes. And the resolution, you mentioned resolution, is always dependent again of what are our needs. For example, if we have the ability to fly really high and our object is very large, for example, a huge mining pit in Peru, if we are flying very high and we have the weather for that, we can actually get by sub 1,000 photo sets, which is again just a very fast process, and it already gives you a realistic view of your site and with no human interference whatsoever. Even the drones are flying by themselves, so it's automation to the maximum.
Fantastic. Lukas and Ian, thank you very much. That was a wonderful presentation. Thank you for participating.